For 7.3, you need to learn how to write your KSP, which is your solubility product, and how to predict whether a precipitate will form or not by comparing your Q to your SP. So when Q is equal to SP, your solution is saturated, but when Q is less than SP, your solution is unsaturated, means the precipitate will not form. But for Q is greater than SP, your solution is super saturated, means there is a formation of precipitate. So this is the one that we want. So highlight this. This is how your equation of SP gonna be. It is this multiplication of the concentration cation with concentration anion to their respective mole. So let's do A. Write the KSP for silver sulfate. So this is our chemical formula. Okay, for KSP, all salt will be in solid phase. Please remember that. Okay, so our silver sulfate will be in solid form and it will partially dissociate to form those Ag plus and SO4 minus. So write down your KSP. So what is your cation? That would be your silver plus to the power of 1, and SO4 minus is your anion to the power of 1 as well. For B, your salt must be in solid form, so it will partially dissociate to form this. So your KSP would be Ba2 plus times with your F minus, but please beware that your mole of S minus is 2, so it should has the power of square. Second question, the solubility of ClCl2 is 1.22 times 10 to the power of minus 8. So look at the unit. This is mole per liter. So obviously this is your unit for molarity. The question asks you to calculate the solubility product of the salt, which is your KSP. So before write down your expression, you need to write the complete equation for your dissociation of solid salt. So CaCl2 will dissociate to become Ca2 plus aqueous and Cl minus aqueous. So the molarity for CaCl2 is 1.22 times 10 to the power of minus 8. So your KSP would be the multiplication of Ca2 plus times with Cl minus to the power of 2. So we've got the molarity of CaCl2. So we know that it has the same mole with Ca2 plus. So Ca2 plus has a molarity of 1.22 times 10 to the power of minus 8. So this one would be just the double of it. So your KSP would be 1.22 times 10 to the power of minus 8 times with 2.44 times 10 to the power of minus 8 to the power of, so you've got 7.26 times 10 to the power of minus 24. Again, KSP is the same as Ka, Kb, it has no unit. Why we can just multiply the molarity for Cl minus? This is because we are talking about the molarity. So if we double the molarity, then you just need to times it with 2. Question 3, you are given experimentally that the KSP of lead-2 chromate is 2.4 times 10 to the power of minus 4. You have to calculate the molar solubility of lead-2 chromate. Okay, highlight that the molar solubility is just the same as your molarity. Okay, like question 2 before. Okay, so you are given KSP and you need to find the molarity of lead-2 chromate, which is PbCrO4. What is the molarity? So from KSP expression, okay, write down your equation first. So lead-2 chromate PbCrO4 would has Pb2 plus and CrO4 2 minus as the products. Okay. So what is the molarity for this one? So you are given the KSP. So we know that KSP is equal to Pb2 plus times with CrO4 2 minus. So we don't know the molarity for both of the products, but we can find it by just square root the KSP unit. Okay, so you've got the X as 1.55 times 10 to the power of minus 2. Okay, so please relate that. So Pb2 plus and CrO4 2 minus both have mole of 1, which is the same as your salt. So your concentration of PbCrO4 would be the same as the product. Alright, question 4, you've got 200 cm cube of BaCl2 with the molarity, and you're adding it to 600 cm cube of K2SO4. The question asks if precipitate form from the solution. So look back at your note. If we want solution to be formed, then your Q must be greater than SP. I'll just write out the story first. So we've got 200 cm cube and molarity of 0.004 molar of BaCl2 and 600 cm cube of 0.008 molar of K2SO4. So we must figure out the total volume, which gonna be 800 cm cube. So that's all the information given together with the KSP for BaSO4. So first step is to write the equation between your both salts. So BaCl2. Sorry, the question already mentioned that it is in aqueous solution. So BaCl2 will react with K2SO4 to form BaSO4 solid plus KCl. Okay, balance the equation. Alright class, so this is our salt because it is in solid form, plus you are given the KSP of it. Okay, next is to write the equation for your salt. So that would be BaSO4 partially dissociate to become Ba2 plus SO4 2 minus. Okay, so you are given the SP, right? So we need to find the Q. Okay. Remember back in chapter 5, so where Q is just the same as Kc or Kp. Okay, so it is the same case for 7.3. So the second step is to find your Q, which is QSP. So it has the same expression as KSP, which is the multiplication of Ba2 plus with SO4 2 minus. So what is the concentration for Ba2 plus and SO4 2 minus in the mixture? Because remember class, we add up all of these to aqueous solution. So we need to find the new molarity for BaCl2 and K2SO4 in the final mixture. So how are we going to find it? So for Ba2 plus comes from BaCl2, right? So first, find the mole of BaCl2, which is 0.004 times with 200 divided by 1000. Using MB over 1000 formula, so you've got 8 times 10 to the power of minus 4 mole. So the new molarity of BaCl2, because we've got a new volume in the mixture, so it just divided the mole with the total volume, which is 800 cm cube. So convert it to liters, so it becomes 0.8 liters. So the new molarity would be 1 times 10 to the power of minus 3. So for SO4 minus, we know that it came from K2SO4. So first find the mole of K2SO4, which is equivalent to SO4 minus. So that would be 0.008 times 600 divided by 1000. So the mole is 4.8 times 10 to the power of minus 3. Next, we need to find the new molarity as well. So the new molarity for SO4 minus would be 6.0 times 10 to the power of minus 3 molar. Now we're going to substitute all this information into your Q. Okay, so lastly, we are able to find our Q as this multiplication of your cation and anion. So we found our QSP. Now we need to compare it to our KSP. So where is our KSP? That would be 1.1 times 10 to the power of minus 10. So QSP is greater than KSP. So that's what we want. I've already told you before. When it's Q is greater than SP, so your solution is supersaturated. So precipitate will be formed. Okay, class, please make a correction on the notes. Okay, just add QSP, and this would be your KSP. Question 5 is the question for common ion effect. So let's say that I have AX solution in a beaker, and then I'm adding a solution of BX. So at the end, the X concentration will increase because it has the same ion. So this is what we call as common ion effect. So look at question. Calculate the solubility of silver chromate. Okay, remember class, solubility, we just need to find the molarity of Ag2CrO4 in A, the pure water. So just write the normal equation for its solubility process, and B, the solution of 0.005 molar K2CrO4. So we know that our CrO4 2- will become our common ion for question 5B. And then lastly is to explain the difference in solubility values. So for this, you must explain whether it shifts to the left or the right and what happened to the solubility. So A, so we know that Ag2CrO4 is our solid. So it will form Ag plus and CrO4 2-. When discussing about common ion effect, we need to write I's table. I's table of what? Of your molarity. Balance your equation. So this one would has 2 Ag plus. Now let's fill in your table. So we know that solid will not be calculated. So your Ag plus would has an initial of 0 because both are products, and the change, this one should be plus 2s, and this one would be plus 1s, or you can just write it as s. So why s? It is because we want to find the solubility, so do not use another alphabet other than s. So at equilibrium, this one would be 2s and this one would be s. So how are we gonna find the value of your products in equilibrium? You are given KSP. So your KSP would be Ag plus squared times with CrO4 2-. Okay, so both will be 2s squared times s, and this one 9.0 times 10 to the power of minus 12. So your s would be 1.31 times 10 to the power of minus 4 molar. So note that this is S, right, 1S, so it represents for 1 mole, which is the same as your silver chromate. So your concentration or your solubility of silver chromate would be this number as well. Don't forget the unit. Alright, for B. So before this, we have Ag2CrO4 in the beaker. Now we're adding it with K2CrO4. So I've already told you that the common ion is the chromate ion. So is there any change to our equation? No. Okay. Ag, so we still have the same dissociation equation with the same table. So the initial molarity for Ag plus would be 0. Okay. The only difference when we are adding common ion effect is the initial molarity of your common ion. So in this case, it is the chromate. So we've already started with 0.005 molar chromate ion. So write this. The initial would be 0.005. Okay, so the change would be plus 2s plus s. Then the equilibrium would be for chromate 0.005 plus S. So now is to find your S volume. So 9.0 times 10 to the power of minus 12. So your Ag plus would be 2S squared, and your chromate ion 0.005 plus S. And class, there's one thing that you need to know. When KSP is greater than 10 to the power of minus 5, then your S is not significant. Okay, this is just the same as we are calculating for our alpha significant. But in this case, we just directly mention that when KSP is greater than negative 5, well, for this one, it is negative 12, then your S at the back is not significant. So we got rid of this plus S. So your calculation only involves this number. So your new S would be 2.12 times 10 to the power of minus 5 molar. Please write this note. It is really important. Because if not, you're going to have S cubed in your calculation. So now let's compare your S value for us to find the difference in the values of solubility. So for solubility in pure water, that would be 1.31 times 10 to the power minus 4. And when in common ion effect, that would be 2.12 times 10 to the power of minus 5. So we can say that the solubility of silver in the common ion effect, which is in KCrO4, is lower than in water. This is because the presence of common ion effect, which is the CrO4 2 minus, increase. So look at your equation. Look at your solubility equation. When CrO4 2 minus increase for question B, so what would happen to the equilibrium? Okay. The equilibrium will shift to the right because we are going from higher to lower. Okay, so this causes the equilibrium to shift to the left. So now, when the equilibrium shifts to the left, your formation of AgCrO4 will increase. So your formation will increase. So this will cause a decrease in your solubility because we are form many solid. Okay, so formation of AgCrO4 increase. So more solid will be formed. So this will, okay, remember class, more solid is formed. So your Ag2CR4 is less soluble. So this will cause solubility to decrease. Okay, so for summarize or to summarize, you need to identify whether your question involves common ion effect by looking at whether you have the same ion involved. Okay, so for common ion effect, you need to write your ice table for molarity for both in pure water and for common ion. And then next you have to explain what would happen to the solubility by looking at which direction the shift gonna be. Okay, for this question it shift to the left. So we are forming more solid Ag2CrO4. So the solution will become less soluble, which means it will be more difficult to dissolve it. So that's all for 7.3.